We're going to look at confidence intervals. So you reject the null hypothesis. Great. So what is a parameter then? The goal of a confidence interval is to estimate a parameter. A parameter summarizes a characteristic of a population. It could be, we've used P, that's a parameter. We've used mu, and of course, there's many others. But sigma characterizes the standard deviation of populations. Parameters are typically, and one could argue, case always, never known. At least for the topics that we care something about. Parameters are thought as the, well, what if we think of as true value? Perfectly describing some characteristic. So this is just a very loose term, but sometimes you hear this, parameters are like the true values. Notice these are fixed. They're not moving, and the only way they can change, only change if characteristics change. That's the only way they can change. The best we can achieve an estimate is an estimate. So when we don't know these, that's all we can get. Which is what? A statistic. So a statistic estimates a parameter. That's the whole purpose. If statistics is a single value, it is often called a point estimate. And for example, the concept of a confidence interval is very general, but we'll use the population proportion P as an example of what we're trying to estimate. That's what we're going to try to estimate with P hat, our point estimate. We could have used the population mean mu as the parameter to estimate, and the sample X bar as a point estimate. And again, these are just two types of parameters. There's others, but definitely these are a good starting point. Here's some of the key vocabulary. Point estimate, range estimate, confidence interval, margin of error. Of course, you can read the rest of these, but as we go through this, come back and every so often look at these and see if you are understanding some of the key vocabulary and some of the key concepts. All right, so before we continue, end it right here to make some comparisons. Hypothesis test. The parameter is assumed to be known. That is the hallmark. Data is gathered to see if there's evidence against the assumed parameter value by using a statistic that estimates the parameter. So again, even though that's true, we don't think of it as that way, and it's also really a point estimate. So the material is still the same. So this number, but however, we're not thinking of it as an estimate at that point. When it comes to hypothesis tests, I'm kind of trying to use the same language for confidence intervals, but it's not. The way we think of it now is evidence against the null, right? Because how do we view this? The point estimate from data set acts as the cutoff. For a set of more extreme possible statistics. So again, we got our statistics, and it's just sort of it's acting as a cutoff for a set of more extreme possible statistics. A hypothesis can be used to, well, here's the kind of big thing. What is it can be used for? Rule out the possibility of a parameter value. In other words, the null. But it cannot tell you what is the true value. So the idea, again, as we already looked at. I'm using P here. This is some value, and we assume to be true. We look at a normal model where this assumed value sits right here. And we're going up against, let's say that this is the alternative. P is greater than some value. And then let's say our P hat value lands here. That means that we're trying to figure out how likely this value is or something more extreme. And this again is acting as my statistic, is acting as a cutoff for this range. But all we're doing is, if we find enough evidence, then we can rule this out. But once we rule this out, the question is, if it's not that, then what is it? Enter the confidence interval. The parameter is not known. That's the logic here. So what I'm describing here is the logic of a hypothesis test, how we view it, versus the confidence interval, how we view it. And in the confidence interval, the parameter is not known. That's the whole point of it. Data is gathered, and from data set, a statistic is calculated that estimates the parameter. And in general, is known as the, again, to re-emphasize, point estimate. Why do we have these different words? Notice I'm emphasizing point estimate in two different places, so this must be important. It is, and I want you to, again, remember that, which is a statistic. So this, what we known as a statistic before, now, because we're doing confidence interval, is known as a point estimate. The hypothesis is really not known as a point estimate because that's not the purpose of it. The purpose is to gather evidence against the null. Using statistic as a center, notice this statistic as a center, a range of possible values is created that could contain the true parameters. So the viewpoint is this. There is no assumption about what the parameter is. Instead, we have this picture. Here's a picture of a confidence interval. Again, notice I'm drawing a normal curve. And see this value? I'm not going to put P naught. This represents an actual value. I don't know what this is. Instead, I'm saying, what is the parameter, the population proportion in this case? And the answer is, I don't know. So what we're going to happen is, we're going to make sure our sample size is large enough so I can draw this curve. This is the sampling distribution of all possible p hats, but in reality, our p hat value will land somewhere. Let's say it landed right here. That's just the naming of the axes. That's where it lands. So then what we're going to do is create an interval around it. Let's say it's that. And the idea is to capture this unknown value. And that's the trick behind this. Obviously, what I drew here, this interval does not capture the parameter. But we are going to see how this works. This, again, is a range of possible values for P. So here's, again, another thing that we want to make sure is clear. Can we figure out what this value is? And the answer is no. Instead, P hat will act as, well, one possible estimate, the one that we got from the data set. And then when we create this interval around this, where this is at the center, so using my point estimate, what we're saying now is this is a potential value that can act as if we have a parameter, but when we create the range, so can these values. What this does is it creates a range, and then we can look at the utmost, say, well, our unknown parameter could be as high as this or as low as that. And that's how a confidence interval works.